Good day, everyone. I'm Shudikin sir. I will be doing the numericals of Nootan, Chapter 1, Electric Charges and Fields today. Now, I'll be doing the numerical in some process. You may have done it in some other way, but you can follow this process also, or you can see how the numerical gets completed in this way, and you can learn from it. Okay, I'll straight away go to the numericals. So, I'll be doing the numerical one first. Calculate the number of electrons to have a total negative charge of 1 coulomb. Okay, so total negative charge of 1 coulomb. We know, according to the question, they have given Q equals to 1 coulomb. We know the charge of an electron as 1.6 into 10 to the power minus 19 coulomb. From quantization of charge, we know that Q equals plus minus Ne. Okay, what they've asked is, they have asked me to find out this value of N. So N will be Q by E plus minus, we can leave it as a mod value, or we can write mod Q by E. What does mod Q means? Mod Q means that mod Q equals to plus Q when Q greater than 0. Mod Q equals to minus of the value of Q when Q less than 0. That means if it is a negative number, that will be negative of the negative number, it will be obviously positive. So mod Q, remember, in simple terms, it will always return a positive. It will also always return a positive value. Okay, now let us come here. Or N will be equals to mod Q by E, that is 1 coulomb by charge of an electron, 1.6 into 10 to the power minus 19 coulomb. Remember one thing, it is a hint. Okay, remember this hint. 10 by 1.6 always give you 6.25. So the value here will be 10 to the power 19 by 1.6. We can write it as 10 into 10 to the power 18 by 1.6. This will give you 6.25, or that will be 6.25 into 10 to the power 18. So this is the total number of electrons. Okay, next question. They are saying 6.25 into 10 to the power 12 electrons are removed from a glass rod. So suppose this is a glass rod, and total number of electrons removed are 6.25 into 10 to the power 12. Okay, they are asking the question that what is the magnitude and nature of charge acquired by the glass rod. Okay, see, they are removing out electron. Now they are asking, after removing the electron, what will be the amount of charge? They are asking this one. Okay, so when you are removing this much amount of electron, that means you are removing this much amount of negative charge. Okay, so the amount of negative charge, the amount of negative charge removed is Q equals to plus minus Ne, right? As I'm already writing negative, so I won't be giving value on this plus minus term. So Q equals to simply Ne. Now N is 6.25 into 10 to the power, they have told 12, into charge of an electron 1.6 into 10 to the power minus 19 coulomb. So this is the total amount of charge. So as I've already told you in the hint in the previous numerical, that 10 by 1.6, this will give you 6.25. So 6.25 into 1.6, this will give you 10. As simple as that. So this term and this term will get multiplied and will give you 10. 10 into 10 to the power 12 minus 19. So that is 13 minus 19, that will be 10 to the power minus 6. Okay. So 10 to the power minus 6 coulomb means 1 microcoulomb. So the question, according to the question, what the magnitude and nature of charge? The nature of, see, when a negative charge is removed out from the rod, Get it carefully. When a negative charge is removed out from the rod, then the rod will be deficient of negative charge. That means it will acquire a positive charge. Okay, it will acquire a positive charge as it is deficit of negative charge. And how much amount of positive charge it will acquire? The amount of negative charge that it has lost. Now according to this question, it has lost 1 microcoulomb equivalent of negative charge. So the positive charge gained by the rod is plus 1 microcoulomb. This is your first answer. Next, they are asking what will be the change in the mass of rod. Okay, so this is part 1. Part 2, they are asking what will be the change in the mass of rod. See, this much amount of electron has been moved out from the rod. What does that mean? It means that the rod will be losing this much mass of charge. The amount of electron they are removing, it will lose that much mass of electron. Okay, that means mass of electron removed, if I write it as capital M, will be n number of electrons are removed into mass of one electron. So that will be 6.25 into 10 to the power 12 into 10 to the power 12 into mass of one electron is 9.1 into 10 to the power minus 31 kg. Now we need a calculator here. So that will be 6.25 into 9.1, that is 56.87 into 10 to the power 12 minus 31. Now 12 minus 31 will be 18, and 18 minus 1, that is 17. So that will be 56.87 into 10 to the power minus just wait, 12, that is 8, and then 10, 18 and 19, that is the minus 19 kg. This is the amount of mass it has lost. Okay, they have given the answer in this way, that is 5.68. They have written 5.625. okay, that is possible only when you take this as 10, otherwise it is not possible. Yes, 5.50, no, less than that. Okay, see, this much error, that is not a big thing. Okay, this much error is not a big thing. You can always accept, you can always accept an error, generally speaking, an error less than around 4%, less than 2%, I must say. You can accept an error less than 2%. Okay, okay, so this will be the answer, that will be 2%. So this will be the answer, that is 5.687. whatever it will come, I'll write that only. Okay, 5.687 into C. I have shifted the point forward, so that will get multiplied by 10. That means that will be 10. That will be multiplied by 10. That means 1 minus 19 kg. So it will become 5.687 into 10 to the power minus 18 kg. This is your answer. Okay, see, in the book they have written it as 5.625 into 10 to the power minus 18 kg, as I'm saying. But see, from the proper calculation of this one, okay, this thing is not coming. So they have given it in this way. They have maybe taken some approximation, I don't know. But whatever the answer which will come in our numerical, we will keep that only, because that is a proper answer. Okay, that is a proper answer. I think they have multiplied it by 9. Let me see, just one second. 6.25 into 9. See, they have not taken it as 9.1, they have taken it as 9. Okay, but the actual mass of electron is 9.1 into 10 to the power minus 31 kg. Okay, whatever, that's not a big deal. Okay, some this kind of things are okay, because it may be due to some approximations, but whatever the result will come in our case, that will be the proper answer for this one. I will also write the answer that is given in the book. If it is tolerable, I will tell that okay, you can go with this one. Next numerical, they are saying a metal surface when exposed to ultraviolet radiations for a short interval of time was found to acquire 10 to the power minus 9 coulomb positive charge. What happened to the metal surface? Now they are saying this is the metal surface, and this metal surface is exposed to a radiation. Now after some time they found out that this metal surface, which was initially neutral, it acquired a charge of 10 to the power minus 9 coulomb, and the acquired charge was positive. Okay, if it is a positive charge, then the first thing is electron is moved away from the plate. So it means the electron is moved away from the plate. So if an electron is moved away from the plate, what does that mean? That means that this much amount of negative charge is lost. So we will find out the number of electrons. So n equals q by e, and that will be 10 to the power minus 9 by q by e, that is 1.6 into 10 to the power minus 19, and that will be 10 to the power 10 by 1.6. Okay, so we can write it as 10 into 10 to the power 9 by 1.6. As I've already told you, this becomes 6.25 into 10 to the power 9. So it has lost a total number of electrons of 6.25 into 10 to the power 9 value. Okay, now the next question is okay, and what happened to the metal surface? So this is the answer. The metal surface has reduced its mass and lost 6.25 times 10 to the power 9 electrons. Next question boleche, next question they have said that is the law of conservation of charge is valid in the following reaction. So the reaction is 44 Ca20 plus 1H1 giving rise to Sc4421 plus 1N0. Okay, so let us look at the number of protons here. So the number of protons is 20 plus 1. So number of protons means they are positive charge. Okay, so number of protons in first reactants we get as 20 plus 1, that is 21. So total positive charge is 21 E minus. Okay, E plus 21 plus of the value of charge of an electron. Okay, total number of protons in products is 21 and 0, that is 21 plus 0, that is also equal to 21. So that is also equals to plus of 21, the charge of a proton. Okay, that means the total positive charge in the reactants and that in the product are same. So we can say that the positive charge is valid. So we can say positive charge is conserved. Now let us come to the negative charge. See, as it is a balanced nuclear reaction, so it's not a nuclear reaction, it's a radioactive reaction. As it is a balanced radioactive reaction, so what will happen is that there will be no involvement of electron as such. Okay, so the number of protons in this case, or the number of positive charge, will be same as that of the number of electrons. Therefore, if it has 21 positive charges in the reactants and 21 positive charges in the products, that means it will have 21 negative charge in the reactant and 21 positive negative charge in the product. Okay, so in that case the negative charge is also conserved. The negative charge is also conserved. Okay. Okay, next question. What is the force between two small charged spheres carrying charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air? Okay, so in the next question they are saying there are two charges. One charge is q1 equals 2 into 10 to the power minus 7 coulomb. Another one, q2, equals 3 into 10 to the power minus 7 coulomb. Okay, now these two charges are separated by a distance. Suppose now that distance is given as 30 centimeter. Okay, this is charge q1, this is q2. Now see, both of the charges are positive charges, so the force that will act will be repulsive in nature. So first property we get is the force will be repulsive in nature, and the value of force from Coulomb's law we get 1 by 4 pi epsilon naught q1 q2 by r square. Okay, now looking at it, we get r is given as 30 centimeter, that will be 30 by 100, 0.3 meter. Now if 1 by 4 pi epsilon, we know the value is 9 into 10 to the power 9 in SI. Q1 Q2 will be 2 into 3, that is 2 into 10 to the power minus 7 into 3 into 10 to the power minus 7 divide by 0.3 and square of it. So that will be 9 into 10 to the power 9 into 3 2s are 6 into 10 to the power 7 and 7, that will be minus 14, divided by 3 square will be 9 into 10 to the power 2. So that will be 9 into 9 9, that will cut away, so that will be 6 into the 9 plus 2 is 11, 11 minus 14 will be minus 3, so that will be 11 minus 14 at the Newton, then that will be 6 into 10 to the power minus 3 Newton. Okay, yeah, this is the answer. So this is the answer, and the force is repulsive in nature. Okay, okay, next question. Calculate the Coulombian force between a proton and an electron separated by 0.8 into 10 to the power minus 15 meter. Now, there are two charges. One charge is a proton, another charge is a electron. So, this is proton, this is electron. Now, charge of proton is equals to charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. Now, it is said that they are separated by a distance of 0.8 into 10 to the power minus 15 meter. Okay, so what is the force acting between them? We know that is 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, so 1 by 4 pi epsilon naught becomes 10 times 10 to the power 10 times q1 is 1.6 into 10 to the power minus 19, q2 is also 1.6 into 10 to the power minus 19, divide by r square is 0.8 into 10 to the power minus 15 and square of it. Okay, let us simplify this. This will easily become, so this is 0.8, so that is 8 by 10, so this will become 8 by 10 into 10 to the minus 15, that is 10 to the power minus 16. So we get 9 into 1.6 into, okay, let us cut out this one also. 1.6 can be written as 16 into 10 to the power minus 20. So we can write them as 16 into 10 to the power minus 20, 16 into the minus, that will be easier. So 9 into 16 into 16 divided by 8 square will be 8 into 8. The power we will do it together, that is minus 40 plus 9 plus 32, because 16 square is 16 to the 32. So this will be 2, this will be 2, 4. 9 4s are 36. So 36 into 10 to the power 32 plus 9 will be 41, plus 41 minus 40, that will be 10 to the power 1. So that will be 360 Newton. Okay. Yeah, this is the answer. Now, what will be the nature of the force? See, this is a proton. Proton is positively charged. This one is electron. Electron is negatively charged. So as they are oppositely charged, they will attract each other. So the nature of the force will be attractive. So that will be 360 Newton and attractive. Okay, 360 Newton and attractive in nature. Okay, next question. They are saying calculate the electrostatic force between two alpha particles separated by 3.2 into 10 to the power minus 15 meters. So there are two alpha particles. Okay, this one is alpha, this one is alpha, and the alpha particle is separated by 3.2 into 10 to the power minus of 15 meter. Now let us do it one by one. First we will be finding out the charge on alpha particle. Okay, this is my first intention. So what is the charge on alpha particle? Alpha particle, we know that is doubly charged helium ion. That means it is the nucleus of helium. It is the nucleus of helium. Now helium nucleus has two portions. There are two neutrons and there are two protons. Now this is chargeless and this has positive charge. Okay, that means the nucleus of helium is doubly positive charge. So the on alpha particle charge on alpha particle is 2 into charge of an electron. Let me write it as E. We know the value of E as 1.6 into 10 to the power minus 19 coulomb. Okay, now so that is the charge on alpha particle. Now they are saying what is the force between them. So let us calculate the force. We know from Coulomb's law, F equals 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, so that will be 1 by 4 pi epsilon naught is 9 times 10 to the power 9. Q1 q2 will be 2e into 2e divided by r square, means that will be 3.2 into 10 to the power minus 15 and square of it. So what will it become? See, this is 9 into 10 to the power 9. Okay, 2e, let me write it as 2 into 2 4. E square will become 16 square into 10 to the power minus 20. See, I have already shown this to you how it is becoming in the previous numerical. I have already shown this to you. See, because 1.6 into 10 to the power minus 19, we can write it in this way. 1.6 into 10 to the power minus 19, this will become 16 into 10 to the power minus 20. So E, this is E, then what will be E square? That will be 16 into 10 to the power minus 20, that square, that will be 16 square into 10 to the power minus 40. Okay, this is what I'm writing here in this portion. So you have to remember some tricks so that your numerical becomes easier. You should remember these tricks. Okay, okay, and that will be divided by the square of this. So 32 into 10 to the power minus 15. Now we can also write it in this way. 3.2 into 10 to the power minus 15. See, we can write it in this way. That will be 32 into 10 to the power minus 16. It will be easier. So if I write it in this way, we can say that this will be 32 square into 10 to the power minus 16 to the 32. Okay, now that will be simple numerical. So 9 into 4 into 16 into 16 divided by 32 into 32 into the power will be plus of 32 minus of 20. Okay, so this is what it is coming right now. Okay, so from here we can say the value as this will be 2, this will be 2, this will cut out as 4. So that will be 9 into 10 to the power 9 plus 32 will be 41. 41 minus 20, that will be 20. That's a pretty high force. What is the answer there? Okay, there is some problem. Maybe the answer is not coming. Okay, just wait. Let me see. Okay, the mistake is that this is minus 40, but I have wrongly written it here as minus 20. Okay, just rectify this thing. This I have wrong. This is minus 40, but I have written it here as minus 20. So this one will get modified. So this will be minus 40. This will be minus 40. And then 41 minus 40. This will be 10 to the power 1. Okay. So that will be 90 Newton. And as both of them are alpha particle, that means both of them are having positive charge. This one is also positive, this one is also positive, so the nature of force will be repulsive. So that will be repulsive. Okay, okay. In the next question, the mutual electrostatic force of attraction between two small spheres carrying charges 0.4 microcoulomb and minus 0.8 microcoulomb in air is 0.2 Newton. Okay, What is the separation between the two spheres? They're asking about the separation between the two spheres. Let us first draw the question. So there are two charges. There are two charges. These two charges are separated by a distance, suppose x or suppose r. And one charge is plus 0.4 microcoulomb. Another charge is minus 0.8 microcoulomb. Okay. Now, the force that acts between them, that will of course be an attractive force. Its value is 0.2 Newton. So they are asking what is the separation between the two spheres. So from Coulomb's law we can write it as 1 by 4 pi epsilon naught q1 q2 divided by r square, or that will be, we need to find out r square. Okay, so r square will be 1 by 4 pi epsilon naught q1 q2 by f, right? So let us first find out r square, then we will get the other value. So that is 9 times 10 to the power 9. Q1 and q2 are 0.4 to 0.8, so that is 0.4 into 0.8. See, both of them are microcoulomb, so that will be 10 to the power minus 6 into 10 to the power minus 6 whole divided by the force. Now what is the force? The force is 0.2 Newton, that is by 0.2. So if we do it in this way, it will be 9 into 4 8s are 32. That is 9 into 32 into 10 to the power minus 2 plus 9 minus 6 minus 6. Okay. Divide by 2 by 10, that will be plus 1. So the value will become that is 16. So 16 into 9. So 16 into 9, that will be 9 6 jar 54, carry 5, 9 ones are 9, 9 plus 5 is 14. So that is 144, okay, into 10 to the power 9 plus 1 10, 6 6 are 12, 12 minus 10 minus 2, that is minus 4. Okay, now this is also not coming. Okay, let us see why is it not coming. Just wait. Okay, just wait. Oh, okay, okay, let us proceed, then we will see. Okay, let us proceed, then we will see. Okay, 0.2. Okay, 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 let us see. Okay, so this is the, this is coming as r square. Okay, so if it is coming as r square, then r will be root over of 144 into 10 to the power minus 4. So that will be 144, its root is 12, root over minus 4, its root is minus 2. So that will be 0.12 meter, or that will be 12 centimeter. Yeah, this is the answer. Okay, okay. Next question says, how far apart the two electrons be if the force between them equals the weight of an electron? Okay, and what in case of protons? Okay, let us do the first part first. How far apart the two electrons be if the force between them equals the weight of an electron? Okay, so the force between them equals the weight of an electron, they are saying it. Okay, so this is an electron, this is the first case. Okay, we are doing the first case, we are doing the case 1, we can say. There are two electrons and they are asking that how far will it be, what will be this distance r if the force that is acting here, that force equals to weight of an electron. So first, from Coulomb's law we can say, from Coulomb's law we can say F equals 1 by 4 pi epsilon naught q1 q2 by r square, and that is equal to mg. We need to find out r square. So what will be r square? R square will be 1 by 4 pi epsilon naught q1 q2 by mg, right? So 1 by 4 pi epsilon is 9 into 10 to the power 9. Both of them are electrons, so square of electron is 16 into 16 square into 10 to the power minus 40. We have already discussed this one. and mg, mass of an electron, is 9 into 10 to the power minus 31 kg. G is 10. Simple. So this is 9 and 9 will cut out, and that will be 16 square into 10 to the power minus 40 plus 31, okay, minus 1 plus 9. So minus 40, minus 42 minus 41 plus 31, that will be minus 10. Minus 10 plus minus 10, okay, plus 9. So that is coming out as 16 square into minus 10 plus 9 is minus 1. Okay. Okay. So R will be equal to 16 by root over 10, because 10 to the power minus, this means that this will be 16 square by 10, right? So 16 by root over 10. Now 16 by root over 10 means approximately 3.16. So let us do the calculation. That will be 16 divided by 3.16. So it becomes 5.06. So that is 5.06 approximately. Okay. The answer is given as 5.1. The answer in book is 5.1 meter, but this is good. Okay. Acha. Next they are asking what will be that in case of protons. Okay, so case 2, we can do it in a shortcut way also. That will be easier, because the cases will be same, only the mass will be replaced, as the charge of the proton is equal to the charge of the electron. Okay, but we will be doing it in the formal way only. So that will be F equals 1 by 4 pi epsilon naught q1 q2 divided by r square equals to mg. Here the mass is only replaced by mass of proton, because charge remains same. Or R will be as usual 1 by 4 pi epsilon naught q1 q2, that is e square, by g into m. Now everything will be same, only one thing will change, that is the mass of proton. So 9 to 10 to the power 9, e squared will be 16 square 10 to the power minus 40, sorry, 10 to the power minus 40, and divided by g. G is 10. M is 1.7 into 10 to the power minus 27 in SI, this much kg. Okay, so let us do the calculation. That will be 9 into 16 square divided by 1.7, okay, into 10 to the power minus 40 plus 27 minus 10 minus 1 plus 9. Okay, so this becomes 9 minus 1 is 8. So 8, 27 plus 8, 27 plus 8, that will be 7 and 8, that is 5, carry 1, 2 and 1 3, that is 35. 35 minus 40, that will be minus 5. So 9 into 16 square into 10 to the power minus 5 divided by 1.7. So this is going to be r square. Okay, this is going to be r square. So what will be r? R will be root over of that. So if we do, okay, 1.7 is 1.7, 17 by 10. That means 10 to the minus 1, it will go top and it will be plus 1. Okay, so this becomes as 9 into 16 square 10 to the power minus 4 divided by 17. Okay, so on doing the root, we get 3 into 16 into 10 to the power minus 2 divided by 17, that is root over 7. Approximately root over 17 is 4. By approximation, if we do, this will come out as 4, and this will be 4. 4 is at 12. Approximately that is 12 into 10 to the power minus 2 meter. That will be 12 centimeter. Okay, yeah, this is approximately. But if we do it properly using the calculations, then let us see what will be the answer. By calculations, let us do it. Okay, so root over of 17, that becomes 4.123. Just remember this one, 3 into 16 by 4.123, 10 to the power minus 2. Okay, so we are doing this one, so that will be 3 times 16 divided by 4.123, so 11.642, so that is 11.642 into 10 to the power minus 2, so that will be 11, or in meter we can write it as 0.1164 meter, or approximately we can write it as 0.116 meter. Okay, this is the answer. In book it is given as 0.117 meter, but this is good. Okay. Okay, now I will like to show you a shortcut on this method. Okay, this is not required, but if you want to do this shortcut, you can do. The shortcut is, we have found out this value. Okay, we have found out this value. So from here, from the case of electron, what we can write, that r square, this is for electron. Okay, that will be 1 by 4 pi time, let me write it as Ka into E square divided by mass of electron into G. And if I say Rp square, that is the distance for the proton, that will be K into E square by mass of proton into G, right? Now if I divide it, because I know this Re, this has already been found out. Okay, so Rp square by Re square, that will come out as Me into G by Mp into G. Okay, so Gg will also cut out, so that will become Me by Mp, or Rp will be root over Me by Mp into Re. Now I need to make sure that you know this thing. What will happen if I divide? Now this is a note. Okay, mass of proton by mass of electron. See, mass of proton is 1.67 into 10 to the power minus 27 kg. Mass of electron is 9.1 into 10 to the power minus 31 kg. Okay, so if we divide them, we get 1.67 by 9.1 into 10 to the power minus 27 plus 31. Now minus 27 plus 31, what does that become? Minus 27 plus 31, that is 4. Okay, so if I just do this calculation, see what comes out. 16700 divided by 9.1, that is 1835 point something, approximately that is 1836 times. Okay, so Mp equals to 1836 mass of an electron. You must remember this thing. Okay, now if we go from here, so that will be Rp equals to, so if we go there again, that will be Rp equals to root over Me by Mp into Re. Now if we put this value here, so that will be 1, this Me by 1836 Me into Re. So Me will cut away. Re, we have just found out this one as Re, we have just found out this one as 5.1 meter, or 5.06, whatever you put, or 5.06, let me write, times 5.06. So that will be root over, okay, 1.8, okay, let me do it in another way. That will be 1 divided by 1836. Now root over of the answer will be 0.0233. That will be 1, that will be 0.0233 into 5.06. If I multiply that, what will I get? Into 5.06, that is 0.118, approximately 0.118. See, it is coming near to this value, right? So that is also a way of doing it, and this answer is also right. Okay, so you can do it in the shortcut way, or you can do in the traditional way. Whatever the process you do, both of them are perfectly right. Okay. Next question is question number 10. Two positive charges distant 0.1 meter apart repel each other with a force of 18 Newton. Okay. If the sum of the charges be 9 microcoulomb, then calculate their separate values. Okay, you have to calculate their separate values. Now, there are two positive charges. Okay, two positive charges. So suppose here is a positive charge, here is another positive charge. Now this charge be q1, this charge be q2. Okay, and according to the question, the distance is 1 meter. The force between them is 18 Newton, and the sum of the charges, that is q1 plus q2, is 9 microcoulomb. Okay. Okay. So from Coulomb's law, what can we write? We write as 1 by 4 pi epsilon naught q1 q2 by r square. Okay. Now let us find out what will be q1 q2. So q1 q2 will be f by 1 by 4 pi epsilon naught into r square. So f is 18 into r square, that is 0.1 meter. That is 0.1 square. So that will be 0.1 square. Okay. Divide by 9 into 10 to the power 9. So this becomes as 2. So 2 into 10 to the power minus 9 minus 2. 0.1 square will be 10 to the power minus 2. So that will be 2 times 10 to the power minus 11. Or we can write it as 20 times 10 to the power minus 12. This will be easier. So this is 20 times 10 to the power minus 12. Acha, we can write it in another way also. 20 into 10 to the power minus 6 into 10 to the power minus 6. Okay. So this becomes 20. 10 to the power minus 6 we are writing as mu. 10 to the power minus 6 we are writing as mu. So we can write it as 20 mu. Okay. This is another way of writing, because in this way if you write, it becomes much easier. You don't need to put the units because the unit will be coulomb square. You are doing pure mathematics. Okay. Now what you get from here is that q1 q2 is 20 microcoulomb and q1 plus q2 is 9 microcoulomb. Okay. Acha, we can do it by a vague approximation, or we can do it in the form of quadratic equation. Both of the processes we can do. Okay, we can do in both of the ways. Okay, so the first way in which we are going to do is q1 and q2 is 20 microcoulomb. So if we take, if q1 equals to 4 microcoulomb and q2 equals to 5 microcoulomb, okay, if we take in that way, then can we say q1 q2 will be 4 into 5, 20 microcoulomb. So this is satisfied, and q1 plus q2 is 4 plus 5, that is 9 microcoulomb. So see, this one is also satisfied. So this will be your answer, that is q1 equals to 4 microcoulomb and q2 equals to 5 microcoulomb. Okay. So this is a way in which we can do. We can do it in another way also. So if you are good in mathematics, I hope you can follow this way. Okay. So from the above part, we have got q1 plus q2 equals to 9 microcoulomb. So can we write it as, and we have also got q1 q2 equals to 20 microcoulomb. Okay. Now can we write this as, q1 minus q2 square, that will be q1 square plus q2 square minus 2 q1 q2, or that will be q1 square plus q2 square minus 2q1 q2. We are just adding 2q1 q2 and subtracting 2q1 q2, so that this term sum becomes 0. Okay, now can we do it in this way? If it becomes q1 square plus q2 square plus 2q1 q2 minus 4q1 q2, so that will be q1 plus q2 its whole square. This term becomes this one minus 4q1 q2. Okay, now from this expression you just note it down, because next time if we will be using this, we won't be doing it again. Okay, so take it as a note work, take it as a note work and practice this thing. What you have to remember is that q1 minus q2 whole square becomes q1 plus q2 whole square minus 4 q1 q2. Okay, okay, let us put the values. So q1 minus q2 we want to find out. q1 plus q2 we have already got as 9 micro, that square, minus 4 q1 into q2 is 20 micro, or q1 minus q2 square will become 9 mu square, that is 81 mu minus 4 into 20, that is 80 mu, or q1 minus q2 will become 1 mu. Now that will become q1 minus q2 1 mu and root over of 1 mu. So 1 mu will come out, that will be q1 minus q2 equals mu. Okay, now we already know q1 plus q2 equals to 9 mu. q1 minus q2 we just found out as mu, so simply this will cut away. 2q1 will be 10 mu, or q1 will be 5 mu. Similarly, putting it in any one, that is 9 minus q1 minus q2 equals to mu, or q1 is 5 mu minus q2 equals to mu, or q2 equals to 5 mu minus mu, that will be equal to 4 mu. So the answers are, the charges are 5 mu and 4 mu. Okay, so you can do this numerical in this way also. It's a good numerical. Okay, next numerical, they are saying that the distance between two negatively charged dust particles is 1 millimeter. So suppose this is a negatively charged dust particle and the distance between them is 1 millimeter, that is 10 to the power minus 3 meter, and with a force of, and they repel each other with a force of 4 into 10 to the power minus 5 newton. So the force acting between them is 4 into 10 to the power minus 5 newton. If the charge on one particle is 4 times that of the other, that means if this charge is q, then this charge will be 4q. Then find out the number of electrons charging them separately. The charge on electron is 5 by 3 times 10 to the power minus 19 coulomb. Okay, they are asking that you have to find out how many electrons are charging this q and how many electrons are charging this 4q. Okay, so if anyhow we can find out the amount q, we can divide it by the charge of an electron and then we can get the value of n1. So this can be a good process. Okay, for that we need to find out q. Now we know F equals 1 by 4 pi epsilon naught into q1 q2 by r square. So we need to find out q. So we will be putting the value of F, 4 times 10 to the power minus 5. This one will be 9 into 10 to the power 9. That will be 4 into q square, and r square will be 10 to the power minus 3 and square of that. So from it we get, okay, we can cut out this one, then q square will be 10 to the power minus 5 minus 9. Okay, divide by 9 to 10, that will be plus 9. Okay, plus 9, and then divide by 9. So it is coming in this way. Let me see it again. Minus 5. Oh, this is minus 6, sorry. Minus 5, and this will go that side, that will be minus 6. Minus 5 minus 6, and that will be minus 9. Yes, so it becomes equals to 10 to the power minus 20 by 9, or q will become 10 to the power minus 10 by 3, because if it is q square, then 3 square will be 9. So if we do the root of that, this one will come. Now we know n1 equals to q by e, that is 10 to the power minus 10 by 3, and the value of e is given as 5 by 3 10 to the minus 19 coulomb. So e will put 5 by 3 into 10 to the power minus 19, so it will become 10 to the power 19. Now this will cut away, that will be 10 to the power 9 by 5, or 10 by 5 into 10 to the power 8, that will be 2 into 10 to the power 8 electrons. So we have found out n1. Now we will be finding out n2. So n2 will be equal to 4 times q by charge of an electron. So 4 times of this, that is 4 into 2 into 10 to the power 8, that will be 8 into 10 to the power 8 electrons. Okay, this is the answer. Okay, next question. Two point charges of plus 10 microcoulomb and plus 6 microcoulomb repel each other with a force of 12 Newton. So suppose this is plus 2 microcoulomb, and a little bit away from here, this one is plus 6 microcoulomb. Okay, so they are like charges, both of them are positive, so they will repel each other. Now the force with which they repel each other, that force is 12 Newton. Okay, now they are saying if each is given an additional charge of minus 4 microcoulomb, then what will be the, okay, now if this distance is r, they are not changing the distance r. Okay, they are keeping the distance same, but they are adding minus 4 coulomb to each, minus 4 microcoulomb to each charge. So this will be plus 2 minus 4 microcoulomb, and this will be plus 6 minus 4 microcoulomb. So this one becomes as minus 2 microcoulomb, this one becomes as plus 2 microcoulomb, and the distance is same. So this time if it is f1, say this is f2, that will be 1 by, well, it is right, it is k q1 q2, that is 2 into 2 divided by r square, and this time this will be k into 2 into 6 by r square. Okay, now as r and r are same, and we know this fact, so if we divide uh 2 by 1, if we divide 2 by 1, what are we getting? If we divide 2 by 1, we get f2 by 12 will be, see, kk will cancel out, r square will cancel out, that will be 2 times 2 divided by 2 times 6. Okay, so this will cut away, so, or f2 will be, this will cut out to be 4, so this 2 will be 4 Newton. And see, in the previous case, this one is also a positive charge, this one is also a positive charge, but later on one charge changed to a negative and another charge became positive. So this was a repulsive in nature, this was repulsive in nature, this will be attractive in nature. Okay, so the answer will be 4 Newton, and that will be attractive. Okay, so this is your new answer. Okay, chalo, next question. Two identical metallic balls A and B having charges plus 40 and minus 10 microcoulomb respectively, the distance between them is 2 meter. Okay, so one ball is plus 40 microcoulomb, another ball is minus 10 microcoulomb. Let this be ball A, this be ball B. Okay, and the distance between them is 2 meter. What is the magnitude and type of force? This is positive, this is negative, so Type of force will be attractive, sorry, as they are oppositely charged, this will be attractive. And the force between them, from Coulomb's law, we have K q1 q2 by r square. We know the value of K as 9 times 10 to the power 9. The charges are 40 and minus 10, so that will be 40 into 10 into micro, that will be 10 to the power minus 12. Thereby r square will be 2 square. Okay, so 2 square is 4. So 2 square is 4, that means 2 square is 4. So we can simplify it easily. 4, this will be 10. So that will be 9 into 10 to the power 9 plus 2 minus 12. 9 plus 2 is 11, minus 12 is minus 1. That will be 9 by 10 or 0.9 Newton. Okay. That is the first answer. Now they are saying what is the magnitude and type of force acting between them. Okay, next is they are touched to each other and again separated by a distance of 2 meter. Okay, so then we are touching them together. So previously this was 40 microcoulomb and this was minus 10 microcoulomb. So when we touched them, the total amount of charge after annihilating the minus 10 microcoulomb, it remains as 30 microcoulomb. Now we are separating them again. So if we like separate them again, so 30 coulomb will get divided. So this is A, this is B. Then A will get 15 microcoulomb, B will also get 15 microcoulomb. Now it is said that they are again separated by the same distance, like 2 meter. So the new force will be 1 by 4 pi epsilon naught q1 q2, that is 15 microcoulomb into 15 microcoulomb by 4. So the answer becomes 9 times 10 to the power 9 into 15, 15 is a 2 to 5 into micro square is 10 to the power minus 12 divided by 4. Okay, now this is going to be a pretty tough numerical. Okay, yes, this is going to be a pretty tough numerical. Okay, we can try it, we can of course try it. So 2 to 5. Okay, that will be a big calculation, so let us do it by calculator, that will be easier. So that will be 2 to 5 times 9 divided by 4. So that becomes 506.25. So 506.25 times 10 to the power 9 minus 12. So that is minus 3. So that will be 0.50625. I don't need to write. Okay, so this much Newton. And as both of them have become positive charges, so this will be repulsive in nature. This will be repulsive in nature. Okay, so our answer becomes 0.506 Newton and repulsive in nature. Okay, now we will go to question number 14. So that says two similarly and equally charged identical metal spheres A and B repel each other with a force of 2 into 10 to the power minus 5 Newton. So this is A, say this one is B. Okay, and they're identical. That means two similarly equally charged and identical. So they are identical and they have equal charge Q. And they are separated by some distance which they have not told. Suppose this distance be x, and the force between them is during this time it is 2 into 10 to the power minus 5 Newton. Okay, so we can write this one as K into Q square by x square. So this is this one. Now they are saying a third identical uncharged sphere C is touched with A. Okay, so we are touching C with A. So this is A. We are touching C with A. Okay, we are touching C with A. So the charge will get divided, and then what we are doing is that the then placed at the midpoint between A and B. So we are placing C in between A and B. So if this one is C, we are placing C between A and B. Okay, we are placing C between A and B. Then we have to find out the net electric force on C. Okay, so what will be the net electric force on C? So this is A, this is C, this one is B. Okay, and this is Q by 2, this one is Q by 2, this one is Q. Okay, so what is happening is that the distance between A and C and the distance between B and C, both of them are absolutely same. That means in the previous case, if it is x squared, okay, let us do it in this way. It will be easier to formulate. Let us write it as 2x so that it becomes easier to do. So this will be 2x square. Okay, now here what is happening, if the previous one it was 2x, this will be x, this one will be x. See, the distance remains same, but it is at the midpoint. So the force on C by A, that is, we will call it as FCA, that is repulsive, and the force on C by B, that is FCB, that is also repulsive. Now we can see that the amount of charge in B is much more than that in A, so the force FCB will be greater, so this one will be greater. So net force will be FCB minus FCA. Okay, let us write down the forces first. So from the figure, FCB, that will be K, and Q1 Q2, that is Q into Q by 2 by x square, and FCA will be K into Q by 2 square by x square. So FCB minus FCA, that will return the value K into Q square by x square. For FCB, we can write it as half, minus for FCA we can write it as 1 by 4. Okay, so this one will become K Q square by x, half minus 1 by 4 will be half, so we can divide it by 2. This is the net force. Now see, K into Q square by 2x square, or we can write it as K into Q square by 4 into x square. This value is this much. Okay, so what we will be doing here is that we will multiply it by 2, divide it by 2, so that becomes twice of K Q square by 4, this is x square, by 4 x square. Okay, now we will be putting this value, Kq square by 4x square is 2 into 10 to the power minus 5, so that will be 2 times 2 into 10 to the power minus 5, that will be 4 into 10 to the power minus 5 Newton. Okay, let us check the answer. Oh, it is showing 2. Okay, okay, let me see. Okay, the problem here is simple. This is a calculation mistake, that is half minus 1 by 4. Okay, now half minus 1 by 4, this value is 1 by 4, and I have written it mistakenly as 2, so this one will be 4. Then we don't need to write these things, and we will just put the value. So we already know that kq square by 4x square is 2 into 10 to the power minus 5, so we will be putting the value here, so that will become 2 into 10 to the power minus 5 Newton. Okay, and that the direction, see, FCB is greater than FCA, so the direction will be towards A, so that will be the direction of force, the direction of force will be towards A. Okay, okay, next question. Two conducting spheres A and B of the same size are situated at some distance apart. Okay, so these are two conducting spheres. They are situated at some distance apart. So this is sphere A, this is sphere B, and each has a charge of plus q coulomb. Okay, and they repel each other with a force of 10 to the power 5 Newton, minus 5 Newton. So the distance between them is this much. Suppose this distance be x, and the force between them is 10 to the power minus 5 Newton. So what happens is that let us find out the relation. Okay, in this case also let us take the distance as 2x, it will be easier. So the force will be k into q square by 4x square, whose value is 10 to the power minus 5 Newton. Now they're saying a third conducting uncharged sphere C of the same size is first touched with A. Okay, so now first we are touching C with A. So if we touch C with A, as they are identical, the charge will be shared equally. So this will become Q by 2, this will become Q by 2. Now they are saying then with B. So C is first touched with A, then C is touched with B. So if this is C, previously this was q by 2, if we are touching it with b was q. Okay, so in this case the net charge that we will get will be q plus q by 2, that will be 3q by 2. Now if we separate them out, it will be divided into two parts. So if we separate them out again, and if this becomes c and this one is b, so this will be equally divided, so that is 3q by 4 here, and this one will also be 3q by 4 here. Okay, now they are saying calculate the resultant force on C. Okay, since we are the same system, A and then B, then place exactly between A and B. Okay, then we are placing, the new situation is this ball is A, we are placing here C, we are placing here B, and the distance between them remains the same, that is this one is 2x. So this much from A to C will be x, and that from C to B will also be x. Now charge on them are respectively, we can write charge on them are q, A has become q by 2, A has become q by 2, C has become 3q by 4, B has become 3q by 4. Okay, so force of A on C will be along this side, this will be FCA. Force of B on C, that will be FCB. Now we can see that FCB is greater than FCA, so net force will be FCB minus FCA. We will write down the values of FCB and FCB. Okay, so FCB will be K into these two charges, that is 3q by 4 square divided by x square. So that will become K into 9. Okay, we will write the numbers first. Okay, that will be 9 by 16 into k q square by x square. Similarly, we can write FCA as k into 3q by 4 into q by 2 divided by x square. Again writing the numbers first, that will be 3 by 4 2s are 8 q square x square into k. Okay, let us write it in a better way, k into q square by x square. Okay, Achha, let us do the subtraction first. So the subtraction says that will be FCB, that is 9 by 16. Okay, let us take kq square by k square common, kq square by x square common. So from FCB we get 9 by 16, from FCA we get 3 by 18, 3 by 8. So 3 by 8 is actually 6 by 16, so that will be k q square by x square into 9 minus 6 by 16. So that will be k q square by x square into 9 minus 6 is 3 by 16. So this is the value. Now from the previous discussion we have got that kq square by 4x square is 10 to the power, or can we write it from here that kq square by x square equals to 4 into 10 to the power minus 5 Newton. Okay, so let us do it in this way, kq square by x square 4 into 10 to the power minus 5. So this will be 4 into 10 to the power minus 5 into 3 by 16. Okay, so this is 4, and we can write it in this way, 10 into 3 into 10 to the power minus 6 by 4, this becomes 2.5, so that will be 7.5 into 10 to the power minus 6 minus 6 Newton. Okay, let me see the answer. Yeah, and what will be the value of the force? That is 10 to the power minus 6 into 7.5, and the direction is, see, FCB is greater, so that will be towards A. So the force's direction is towards A. Okay, so by this I end the first 15 questions. Okay, keep studying them.